talk to a friend, how can we prove? Everybody seeing the quotation mark? How can you prove beyond a shadow of a doubt that those triangles are congruent? Any extras? Everyone get a sheet of triangles. How can we know beyond a shadow of a doubt that those triangles are isosceles triangles? Give you a few minutes to talk to your neighbor, talk to your community peers. Okay, all eyes up front. How can you prove that these triangles are isosceles triangles? Anyone take a look? Anyone have any ideas? Yeah. If they what? Okay. How many of you saw the word prove? I want you to do it with beyond a shadow of a doubt. How can I know these are isosceles triangles? We heard the answer. Isosceles triangle has two sides that are congruent. Yes. Okay, even if we put the tick marks, how do I know that those triangles are isosceles triangles? They also have congruent. Can we, understand what you're saying, and that's the definition, but I asked you to prove it by the drawings that you have in front of you.
Do you mean like with a two-column proof?
Yes.
What?
Yeah.
Oh, now we're talking some things. You could actually get a protractor or a what? Ruler. You can measure them. That's one way of proving that there are isosceles triangles. What else could I do? I'm trying to give someone a hint. Everyone hear that? Talk with a friend, talk with a neighbor. Can you fold this paper in any way to prove that the triangles are isosceles triangles? Oh, that was excellent. I like that response. I'll give you another opportunity. Give you a few more minutes. Come on. Oh, I'm looking. This is exciting. I see some people are getting it. We want to know beyond a shadow of a doubt how these triangles are isosceles triangles. Some of you have it already. Let's go with number 4. Okay, I heard something. You can what? You can fold the paper. What does that tell you about the triangle? Remember we talked about rigid motion? When one triangle is superimposed, one polygon is superimposed on the other, the polygons are what? Congruent. Okay? if you fold the paper, and where do you fold it? Let's look at number 4. Where would I create this fold to show beyond a shadow of a doubt that number 4 is an isosceles triangle? Where? Which way would it fold? The top to the bottom. Number 4?
No, it'll be side to side.
Side to side?
If you take one side and fold.
Okay, I like that. This is a vertical line, isn't it? And if you fold along this vertical line, you can show that one side is congruent or the same as the what? You can show beyond a shadow of a doubt. That's why Mr. Williams said prove. Now, the ruler idea was done. But also without a ruler, you could create a fold. And fold from left to what? Right. Along this vertical line. Who can tell me what this vertical line is called? Yeah. Axis of symmetry? That's a good one. What else? Diagonal? No, that's not a diagonal. Who heard that? It's an auxiliary line that is also a what? A bisector. What do you know about bisectors? They bisect. What else do they do? What does it create? Two congruent what? Sides. Excellent, excellent. Let's look at number 3. Who did some folding of number 3? Okay, where does the fold occur, sir? To show beyond a shadow of a doubt that that is a isosceles triangle. What'd you do? Did everybody see? What is your fold? I think you got it right. Is it this way?
No, it's this.
It's what way?
It's that way.
That's right.
Is it? It's left to right. If you fold along, this is called an auxiliary line. I like that. Like axis of symmetry. That was extremely good. Because you fold it, if you fold it this way, you get two sides that are what? How about number 2? Which way did you fold it? Top to bottom, left to right?
Left to right.
It went left to right. There's our auxiliary line. Okay? Create a bisector. Excellent. How about number 1? Where'd you draw? What'd you fold? What'd you discover about number 1?
You cannot fold.
It's what? He's shaking. He got. It's not a what? It is not. If you fold it, you will not get any sides that are congruent. Okay? It is not an SOSCELES line. What is it called? What kind of triangle is it? Gallon. Excellent job. What have we found out?
But if you don't have a ruler.
What have you found out by doing this? Let me ask you a question, another question. By doing the folding, not only did we see that two sides were congruent, what else did we determine was congruent with our folding exercise?
Yeah, like that we didn't need to take marks, so that our triangle was isosceles.
That may be a good thing. I'm thinking about something else. I'm talking about the labeling. When we folded, we saw that one side was just as long as the other side. We also saw what about the angles? I love that answer. The angles also were what? We're talking about the isosceles triangle theorem. And I want you to give me some idea of what I'm talking about. If two sides of a triangle are congruent, what does that say about the angle? They're corresponding, or what are they? Now I want you to notice something. This side is congruent to that side. This angle is opposite that side. This angle is opposite that side. So if you have a isosceles triangle and the sides are congruent, a triangle and it has sides that are congruent, what does that mean? What does that say about the angles that are opposite? And we'll write it. I'm gonna start writing it. I want you to finish it for me. Okay? You need to write this down. If two sides of a triangle are congruent, then the opposite what? What do we learn about the floor? The opposite what? Angles are what? What word am I writing? Is that what we discovered? Guess what? You have just proved, you have just given me D-O-M. Let's go with some stuff we do know. We know that these two sides are congruent, right?
Oh, yeah, AD.
We're given. What else is a given? Come on up. James, put up number 2. I just showed you. You guys forgot about the fold? We're trying to, it's a isosceles triangle. And what is the reason? I like that. It is also called an angle what? Bisect. Okay, thumbs in the air. Who agrees with that? If we consider the auxiliary line, which represents an angle bisector, call this letter D, we can see that AD is congruent to AD because of the reflexive what? Property. Excellent. Number 3, what do we need to do now? Leah, you want to help us out with number 3? Okay. Who else? Anybody want to help us out with number 3? Okay, what do you know about this? That means that you just created what?
Second line. Or 2 lines.
You got another congruent what? Side. Come on up.
We can't just, I don't want to, we can just say.
Yo, you can come up and write it for us. Thank you. Shereen, you want to come up?
I don't know the reason for it.
You don't know the reason? Well, just help us out. What do you have?
That EB, making reference to BC.
Okay. Are we, do we really know this is a midpoint? We do know this is a bisector.
Oh, so AD does bisect.
But how do you prove the two triangles are congruent?
We need one more side.
Okay, what do we got? We got a side, we got a side. What are we missing?
Another side.
Oh!
XXX.
Who's not seeing it? I think Shereen mentioned it. What are we missing? We got a side and a side. What are we missing? We're missing what? Who has it? Very, very good. What angle? When you put the auxiliary side down, this becomes a what? A bi what?
Angle bisector.
Angle bisector creating two what? Congruent angles.
Both side and both side.
So what angles now do we have?
You have a side.
What angles do we have? Someone come up for number 3 and put the angles in. Show me why they're congruent. Okay, any volunteers? Okay, let's work it out together. That means that angle what? BAD is congruent to what angle? CAD, very good. And the reason? Definition of what? Definition of angle bisector. Everybody got it? Now, that means, what are we ready to do? We got a side angle side, what can we do now? We can show that two what? Anybody want to come up and write that for us? Anyone? Okay,
Right, BA.
okay, let's put it up.
BA.
Okay, that means that triangle what? BAD. BAD is congruent to triangle what? CAD. And because of what? Side, angle, side. We're still not done. Who can see the last step? Come on up, put it on. No, we're gonna. Are you thinking about the reason? You've got two triangles that are congruent. How do you know the angles are now congruent? What is the reason? Can you help him?
You did it correctly.
Yeah.
Let me see thumbs.
Yeah, that's right.
Any up in the air? How about a no vote? Excellent, excellent job. Then now we know these two angles are congruent. Because corresponding what? Parts of congruent triangles are CPCTC. Can I hear you say that? CPCTC. We just proved